In this section, we're going to take a quick look at some parametric equations. Here I've written we want to eliminate t in graph, and I have x equal 3 cosine t, y is equal to 3 sine t. So these two equations together are considered parametric equations, and x and y that we usually see on our coordinate system are given in terms of a third variable t, which we call the parameter. Now, just to get used to parametric equations to begin with, one of the things we like to do is eliminate the parameter t, see what kind of equation we get that just has x and y in it, and then see if we can graph it. So I'm going to solve this first equation for cosine t. Cosine t is equal to x over 3. I'm going to solve the second equation for sine t, and I'll get sine t is equal to y over 3. Now, I can eliminate this parameter t by noticing that sine squared t plus cosine squared t will be equal to 1. So sine squared t is going to be y squared over 9. Cosine squared t will be x squared over 9. And that's equal to 1. If I multiply both sides by 9, and let's see, I'll write it in kind of standard form, x squared plus y squared is equal to 9. So this will be a circle with a center at 0, 0 at the origin and a radius of, not 9, but 3. So I won't graph that for you. I mean, I'm sure you can visualize the graph of that circle. But it turns out when we eliminate this parameter t, this third variable t, we end up with just x squared plus y squared is equal to 9. Well, I know that that's going to have a graph that will be a circle with a center at the origin and a radius of 3. But the important thing to notice about this is it does not contain the variable t. So I've taken my two individual equations here, and by a sort of a form of substitution with this Pythagorean identity, I've eliminated that variable t, and I end up with an equation that has just x and y in it. Let's try one more. We have here, we want to just eliminate t here and not sketch the graph, and we have x equal 2 plus 3 tangent t, y equal 4 plus 3 secant t. Now, I know from my trigonometric identities that the relationship between tangent and secant is this. 1 plus tangent squared t will be equal to secant squared t. So if I can solve this for tangent t and this for secant t, I'll just simply substitute into this equation right here, this Pythagorean identity that relates tangent and secant, and I'll have a nice expression that probably is not going to contain the parameter t. So I solve this equation for tangent t. Tangent t will be x, subtract 2, and then I'll divide by 3. So tangent t is equal to x minus 2 divided by 3. I'll solve this for secant t, and I'll get secant t is equal to y, subtract 4, and then I'll divide by 3. So y minus 4 divided by 3. Now I'll take each of these expressions and substitute into this trig identity, and I have 1 plus x minus 2 squared over 9, because I want tangent squared here, and tangent is x minus 2 over 3, so tangent squared is x minus 2 squared over 9, equal this squared, which is y minus 4, quantity squared, divided by 3. Whoops, take that back. Divided by 9. Now, if I multiply both sides of this by 9 and rearrange it a little bit, I'll end up with the equation of a circle. Let's see, well, not quite, I guess. Let's see, I'm going to have 1 is equal to y minus 4 squared over 9 minus x minus 2 squared over 9. So that looks like the equation of maybe a hyperbola with a center at x equal 2, y equal 4, and then these 9s right here will tell us how to draw that little box with the asymptotes. We're not going to graph that because that's kind of a review of some more of the difficult topics from intermediate algebra, but at least we have succeeded in eliminating the parameter t from these two equations right here using this Pythagorean identity, and we end up with an equation that just has x and y in it.